is the second part of PEAS, front-end engineering, design. Oops. So my part is composed of concurrent engineering and change management and supply chain management and process design and P&ID. See that? So there are so many components inside the offshore or ocean plant. We may say millions of them, and they are dependent on each other rather than independent. And security is also important, and also so that management is important. Especially the schedule management or change management is. Now this is about the disaster in Gulf of Mexico inside the United States 12 years ago. And there is also a movie about this disaster. It has been a big and long explosion. So we must to handle this kind of complexity and dangerous safety. So design process is, we are more focused on engineering in the center. And engineers need to talk with the client. The client should be usually the oil major and customer. And then design basis is a starting point or design requirement is given by the client. So that can be the input to the engineering. And output coming from the engineering work, it should be construction document, usually the drawings. And also the document for purchase. Purchase means the equipment outsourcing. And that goes to the vendors. Vendors means the equipment suppliers or equipment manufacturers. Because million parts are assembled together, many of them, an increasing number of them, are outsourcing. So we need to have more and more dependency on equipment suppliers. All right, so that here the right hand side, the output is more elaborated. So cost estimation and document for inquiry and client engineering basis and material requisition and deliverables. Okay. And what is concurrent engineering? In old days, we do work as a sequential way, so that engineering means the designing. After designing finished, we start to buy or procure the equipment, millions of them. And after purchasing, construction started. But nowadays, because of the competition in the market, we needed to reduce the time to market so that the works overlap each other, not sequential, they are parallel now. So we call this as a concurrent engineering. Because of the limited time to speed up. So in the old days, EPC was separated out one by one and finished, and then started and finished and started. But nowadays, concurrent engineering, the engineering cycle, procurement cycle, and construction cycle is somehow overlapped in parallel each other. To make the concurrent engineering working correctly, we need to have the design input early, avoid changes and integrations, so that there must be some data inconsistency problem, configuration management, and change management is important. Important than the previous sequential way. So we need to have a more higher level of management, engineering, process management. So the process design started at the early stage, the process for the chemical process. And then equipment is listed up based on process simulation, and then equipment inquiry to the vendors, and then vendor company, the equipment suppliers or manufacturers, and they supply or manufacture, and then delivered, then we need to installation of equipment. So nowadays, because outsourcing is increasing in terms of size and money, and supplier relationship is more important than this. So here, if there is something wrong with the supplier implementation, say something like a piece inside a red circle, or it is not easy to fixing up. So the estimation or scheduling for the simulation is important, right? The correct engineering is important, but it's not easy, right? So previous simulation beforehand, any simulation helps us to reduce the time to market. So change management is also complex and important. So source of changes is something like technical issues and reviews, and client has they change mind. And also third party means vendors who provide equipment. They have different models and also interface. Interface means a connection between assemblies. So, but change in the later stage is very ugly. So it costs much. So that front-end engineering is important more because many things can be fixed in the early stage. So suppliers or vendors or subcontractors is increasing in terms of money and numbers. So we need to have a quality and schedule of suppliers is more important than before. So you need to have an inspection for the quality, and also supplier work process should be checked to keep the scheduling, and then implementation and access system. So here is something like a project management. So PM is important for project management. We need to manage engineering, procurement, and site means a construction site. And then control manager, project control manager is to help project managers. And process design, it is short name of chemical process. So there is a short name called process flow diagram, PFD, and that output comes to material balance, and then finally we get the equipment list, and that can be purchased. And utility flow diagram and safety process data, piping process data, that are all related with PNID. PNID is piping and instrumentation diagram. Okay. So we'll see what is PNID. And so design criteria, they have a design factor database, see the process simulation for the process design, chemical process simulation engineering, resulted in PFD and UFD, and then finally PNID is the output of feed engineering, of chemical process feed engineering. So here is a sample of PNID, the piping and instrumentation diagram. So there is an equipment connected through the piping. There is some gateway, something like that, valve and all. So diagram shows the connection between equipment to do the chemical process. So let's see what is PNID looks like. Do the video. Okay. Where is the video?
北海道でも大人気。
チクタクチクタク。世界で日本でナンバーワン。
洗練されたセンスを感じるようなショップカードにしたいなと思ってます。
In many of our RealPars videos, we discuss control system and instrumentation devices in great detail, so you can understand exactly how they work. In this video, we will learn how to read a P&ID, which is something that engineers encounter on a daily basis. At RealPars, we love helping you learn. So if you enjoyed this video as much as we enjoyed making it, click the like button. Subscribe and click the bell, and you'll receive notifications of new RealPars videos, so you'll never miss another one. P&IDs, or piping and instrumentation diagrams to give them their full name, are schematic representations of pipelines, equipment, instrumentation, and control systems found in process environments such as oil refineries, chemical plants, paper mills, and cement plants, etc. The symbols contained in P&IDs represent the equipment in the process, such as actuators, sensors, and controllers. Process equipment such as valves, instruments, and pipelines are identified by codes and symbols. As well as devices and pipelines, a P&ID will commonly contain information on vents, drains, and sampling lines, as well as flow directions, control I/O, and interconnection references. The instrumentation codes listed in P&IDs follow a standard format. After some practice in reading P&IDs, you'll know these codes by heart. But in the meantime, there are many resources on the web where you can download these tables for reference. The first letter of the code identifies the parameters that are being controlled or monitored. For example, flow, temperature, level, or pressure. The next letter is used to define the type of control device being used. For example, transmitter, valve, or controller. The number refers to the logical numerator. For example, we may have a system with 4 temperature transmitters. It makes sense to identify these as TTO1, TTO2, TTO3, and TTO4. Let's get.
All right. That's enough for today. So you have more reading in the later stage, because we have a link address there. So chemical process design again, the output is coming from PFD and P&ID. So P&ID is important, and piping instrumentation, and also the equipment list or equipment specification. That is for purchasing or procurement. So that goes to the vendor drawing and then other things. And this is for the topside engineering for offshore, and then that gives you similar things, the design basis, process simulation, PFD, UFD, and the PNID. And then we will have a more piping and sizing and then equipment purchase. Okay. All right, that's for today. Any question from me? No. Then we go on to the second part of